Okay, so let's start talking about something called transition metals. So we're still talking about ionic compounds, and another situation that you're going to come across in an ionic compound are something called transition metals. So if we just look at the periodic table, again, drawn badly. So here's my periodic table. Here is my metalloid staircase. So we said everything over here, these are all metals, and then everything over here, these are all non-metals. Well, actually, everything in this middle group right here, this D block, back when we were talking about electron configurations, these in this row of 10, this D block, these are all called transition metals. And there's actually some over here that are also included in the transition metals. So the transition metals are found, they're here in this middle part of the periodic table. And again, like lead, even though it's not here, is also another example of a transition metal, and here, tin. So what the deal is with transition metals is that they can have more than one ion. So you cannot look at a transition metal and its position on the periodic table and tell what the ionic charge is based on the distance from the nearest noble gas, the one with the full octet. So you can't look here and say chromium is here and it would need to lose this many electrons to be like its nearest noble gas. You cannot do that for the transition metals. Transition metals, you must be told the charge of the ion. Because for transition metals, there are more than one possible charge. So for example, let's say iron, which is a transition metal, iron is right here, Fe, another one that does not have an atomic symbol that the name starts with. Fe is actually the beginning of the Latin word for iron, which is ferrous. So Fe, there's 3 ions for iron. There's iron 1, iron 2, and iron 3. So we would say it like this. Whoops. Iron 1, iron 2, and iron 3. So we have to be told the charge of the ion, and we're told in Roman numerals. So if there was an iron 4, which there's not, but if there was an iron 4, it would look like this. But again, iron 4 is not a thing. But there are some ions that have a 4, like there's a lead 4, I think there's a tin 4, there's different ones that have a charge that has 4. So these are transition metals, which means they are still metals. Remember that all metals are positively charged. So when it says iron 1, that means Fe plus 1. When it's iron 2, that's Fe2 plus. And when it's iron 3, that's Fe3 plus. So again, transition metals are always positive. They're always positive because they're metals. And metals always form positive cations. So you have to be told the charge in the name of the ion, or you can figure it out based on what it is bonded to in its formula. So all 3 of these, let's say all 3 of these form a compound with oxygen. So let's say we were to have iron 1 oxide, iron 2 oxide, and iron 3 oxide. These are all 3 different compounds, and they would all have 3 different formulas. The oxide doesn't change. We know that oxide has a charge of -2. Regardless of what it is going to be ionically bonded to, oxide is O2- for everything. So now let's write what would be the formula for these 3. So what would be the formula for iron 1 oxide? What would be the formula for iron 2 oxide? What would be the formula for iron 3 oxide? So like I said, I'm just going to write out the ions here. Separately, and then we'll write the formula. So the ions that I'm combining here is iron 1, Fe+1, oxide, O2-. So if iron has a charge of 1 and oxide has a charge of -2, it must be, let's write this a different color. Let's do Fe2O. So this formula would be iron 1 oxide because iron has a charge of 1. So now let's look at the ions for iron 2 oxide. So that iron 2 means it's iron +2, 2+. Oxygen is still O2-. So that means the formula is just FeO because this has a charge of +2, this has a charge of -2, so we don't need any subscripts, it's already balanced. So now let's look at the last one. Iron 3 oxide, Fe3+, oxygen is O2-. So again, because these are different, we want the lowest common denominator, which is 6. So I want 6 positives and 6 negatives. So it becomes Fe2O3. Fe2O3 is iron 3 oxide. You also could be given the formula and then work backwards from the formula to figure out what the name is. So let's do some more examples. Let's look at copper and phosphide. So I'm going to say copper 1, copper 2, and copper 3 phosphide. And then we're going to do the same thing again. But I am going to give you the formula, or, let's see. I'm going to do this again. So we're going to say copper 1 phosphide. Copper 2 phosphide. And copper 3 phosphide. And maybe pause this and then try to do what I did. Write the ions and write the formula. So here is the name. I'm going to make a column for ions. You don't need this, but it's just going to help us get the formula. Okay, so copper 1 tells us that this is Cu+. So copper is again another one, cuprous, which is the Latin word for copper. So copper is Cu, not Co. Co is cobalt. So Cu is copper. So this is copper 1, Cu+1. That 1 tells me the charge. Phosphide, if you find phosphorus on the periodic table, phosphorus is right here. It's in group 5. It wants to be like argon in group 8. So it is going to gain 3 electrons. So it's going to be P3-. So to write the formula, I'm going to need 3 coppers, Cu3P. This is copper 1 phosphide. So now copper 2 is going to be Cu 2+. Phosphide, again, is going to be P3-. These, I'm going to need the lowest common denominator, which is 6. So this is going to be Cu3P2. for copper 2 phosphide. Here, it's going to be copper 3 phosphide, Cu3 plus, phosphide 3 minus, CuP for copper 3 phosphide. We also will do some practice where we go from the formula to the name. And that's a little bit tricky because you have to know that when you're dealing with anything that is in this middle section here, you have to show the Roman numeral in the name. So let's see what a good example for that would be. Maybe just right down here at the bottom. Let's say it is, here's the formula, and I want you to write the name. So the formula is ZnO, so that's zinc and that's oxygen. So if we look on the periodic table, here's zinc. It's a transition metal. Here's oxygen. Oxygen has a charge of -2 because it's going to gain 2 electrons. So if I write the ion here, I don't know what the charge of zinc is, but I do know the charge of oxygen is 2 minus. And this tells me this is balanced. So if I have oxygen and it has a charge of -2, and I only needed 1 zinc to balance that, then zinc must have been +2 because oxygen is -2, which means the name of this is zinc 2 oxide. If you just said zinc oxide, that is not correct because zinc is a transition metal. Whenever you are using transition metals in ionic compounds, you must tell the charge of the ion in the name with a Roman numeral. And we'll do some more practice with this later.